In the frozen emptiness beyond our solar system, something unimaginable has slipped into our reality. It isn't a radio signal, a spacecraft, or even a transmission in any form we recognize. It is quieter, stranger, an object now called 3I Atlas. Unlike any comet or asteroid humanity has ever observed, Atlas streams refined nickel into the void at a rate of 10 pounds per second. Not raw ore, not rocky dust, not cosmic debris, but purified metal, industrial grade, almost entirely free of iron. A signature that no known natural process could ever produce. And now, the James Webb Space Telescope has confirmed the unthinkable. This isn't a comet. It isn't an asteroid. It may be a fragment of technology, or something that falls outside all human categories. More than a discovery, it feels like a challenge placed directly at the feet of humanity. Because if what we're witnessing is real, then the boundaries of what we thought we knew about the universe have already collapsed. It all began on July 1, 2025. In the deserts of Chile, an array of telescopes picked up a fast-moving visitor cutting across the night sky. At first, astronomers classified it as another comet from the interstellar dark. That alone was historic, only the third interstellar object ever confirmed. Its velocity, 130,000 miles per hour, was proof that it had come from beyond the reach of the sun's gravity. But the excitement turned to unease as researchers trained their most sensitive instruments toward its coma, the glowing shroud surrounding its core. What they expected was the familiar cosmic mix: water vapor, carbon dioxide, silicates, organic dust. What they found instead was refined nickel. Only nickel. No iron, no companion metals, no impurities. In the universe, nickel and iron are cosmic twins, born together in the crucibles of supernovae. To find one without the other is like finding water without hydrogen, physically impossible unless something, or someone, has intervened. At Harvard, one astrophysicist said the words others were afraid to speak. This didn't look natural. It looked industrial. On Earth, separating nickel from iron requires enormous energy, advanced smelting techniques, and infrastructure. It isn't something that happens on accident, much less in the vacuum of space. So what was Atlas? A comet engineered to look like one? A fragment of a machine? Or something more cryptic, an artifact designed to draw attention only when a civilization became advanced enough to recognize what it was seeing? When the James Webb Space Telescope turned its infrared eye on Atlas, it revealed even more anomalies. Its chemistry was wrong. Where most comets release a balance of water and carbon dioxide, Atlas's atmosphere was almost 8 parts carbon dioxide for every 1 part water, twice the ratio of any known comet. And then came the orbit. At first, its path looked like a random plunge through the solar system. But as astronomers plotted its motion more carefully, they saw a pattern emerge. It wasn't drifting blindly. It was performing precise flybys of Venus, Mars, and Jupiter, using their gravity in a way eerily similar to how human spacecraft use slingshot maneuvers. The odds of this trajectory forming by chance? Less than 1 in 20,000. More alarming still, during its closest approach to the Sun, Atlas positioned itself behind the star, perfectly hidden from Earth's view, at the exact moment when astronomers hoped to observe its activity most clearly. Coincidence, or strategy? Webb's spectrographs then delivered a revelation that shifted the debate entirely. Atlas wasn't just shedding purified nickel. It was releasing engineered alloys, combinations of elements not known to form naturally anywhere in the universe. Alloys designed for durability, heat resistance, and high stress, materials familiar on Earth only in spacecraft, reactors, and deep-sea engineering. And the release wasn't chaotic. The metals were ejected in precise intervals, as though timed. When charted, the emissions form sequences. Patterns. Almost like a code written in elements instead of words. Some theorists began to argue that this wasn't chemistry at all, it was communication. The emission itself didn't behave like cometary outgassing, which is random and violent. Instead, the flow was smooth, directional, and astonishingly stable. More like controlled microthrust than natural venting. Perhaps Atlas was not simply drifting. Perhaps it was steering. That comparison immediately called to mind Oumuamua, the first known interstellar visitor, which displayed unexplained acceleration back in 2017. But while Oumuamua was small, dim, and elusive, Atlas was larger, brighter, and far more deliberate, almost as though it represented the next step. A scout first, then a probe. A whisper, followed by a statement. The deeper astronomers probed, the stranger the picture became. Atlas's emissions weren't just unusual metals. Among them were exotic isotopes, including technetium, an element that does not occur naturally in stable form. On Earth, it is a byproduct of nuclear reactions. To find it drifting in deep space suggested refinement, not randomness. Even more astonishing, when scientists examined the emission lines of the alloys, they discovered that the metals resonated at harmonic intervals. Translated into sound, the frequencies resembled chords. Not music in the human sense, but structured, like a language written in physics. A universal alphabet inscribed into matter itself. And yet, through all of this, Atlas remained silent. No radio signals. No beacons. No pings. Nothing that could be called a transmission. But perhaps that silence was the loudest clue of all. Any civilization advanced enough to survive the cosmos would know the danger of announcing itself. Broadcasting into the void is a liability. The only safe way to be found is not to shout, but to be noticed. Which raises a disturbing possibility. Perhaps Atlas is not here to communicate. Perhaps it is here to test. To measure not the universe but us. How quickly we notice. How we interpret anomalies. How we respond to impossibility and silence. In this interpretation, Atlas itself may not matter. The metals, the trajectory, the silence, they are simply instruments. The real experiment is us. Every spectrograph pointed toward it, every paper published, every debate sparked across nations, this is our response. And somewhere, perhaps, that response is being logged. If that's true, then Atlas isn't a message at all. It's a mirror. A filter. A quiet evaluation mechanism designed to pass through young civilizations and see which ones are curious enough, bold enough, and united enough to recognize it for what it is. And then comes the most unsettling thought of all, that Atlas may be part of something much larger. A long-running project seeded into the galaxy, with probes scattered across the stars, designed to appear only when civilizations are ready to see them. They don't need to move fast. They don't need to transmit. They only need to drift, patient as time itself, until an emerging intelligence notices the impossible. Perhaps Oumuamua was the first node. Perhaps Atlas is the second. A sequence unfolding not in years but in millennia. A cosmic experiment whose scale dwarfs our understanding. In the end, Atlas may not be a relic, a probe, or a machine. It may be a question, one so subtle, so elegantly placed, that it forces us to change simply by confronting it. Because now we look at the sky differently. We second-guess the silence. We interrogate the dust. We peer deeper into the patterns. And in doing so, we evolve. Not technologically, but intellectually. And maybe, that was the mission all along. Atlas did not come to deliver a message. It came to provoke one. The metals, the orbit, the silence, all of it was the spark. What follows, what we do now, what we choose to believe, what questions we dare to ask, that is the fire. Because the real question isn't what Atlas is. The real question is what humanity becomes, now that we have seen it.